Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the measurement of humidity. Here we will study that what is humidity, then we will see some of the terms related to humidity, why the measurement of humidity is important, and then we will study the methods which are used for the measurement of humidity along with its advantages, disadvantages and applications. So let us start with our topic. Before starting with the methods which are used for the measurement of humidity, let us first understand that what is humidity. So humidity is defined as the amount of water present in the surrounding air. So in our surrounding environment we are having air which is a mixture of gases. So in that air how much amount of water is present, that is called the humidity. Okay. Now why this measurement of humidity is important for us? Because this humidity plays an important role for the humans also. Suppose that we are in a temperature, the surrounding temperature is 0 degree Celsius, but this temperature is having very less humidity. Less humidity means that the amount of water present in the surrounding air is very less. Okay, so we can say that the air is very dry. So in this temperatures, the temperature is 0 degree Celsius, but the air is having very less humidity. So in that type of environment, we will feel comfortable. But if we are having the temperature 10 degrees Celsius and we are having more humidity, so at that temperature we will feel uncomfortable. So you can see that the humidity also plays an important role for the humans, that in what type of environment we will feel comfortable or we will feel uncomfortable due to the presence of humidity. If we are having less humidity, we will feel comfortable. If there is a more humidity, then we will feel uncomfortable. Okay. Not only for the humans but in the industrial applications, in the biomedical applications, for the agriculture and in the electrical and electronics field also, the measurement of humidity is very much important. So it finds its applications in industries, in agricultural field, in medical field, in environmental field also for the weather conditions, and for the electrical and electronics field also. How we can see that in the industries we are having different processes which are going out, and also in industries if suppose that in the surrounding air if the moisture content is more, okay, so if more moisture content is there, then oxygen content will be less and the chances of fire will be less. So you can see that the humidity is affecting the conditions of fire coming out in the industries. Okay. So in agriculture also, if the humidity is changing, then it also affects the growth of the plants. Okay, in medical field, if we see that such instruments like in ventilators, incubators, in that humidity also plays very important role. Okay, because there we want that the amount of water content should be very specific so that the instrument can work properly, and we want that certain things are to be kept at some specific and standard conditions. Okay, like in ventilators, in sterilizers, in incubators, the humidity has to be maintained. So there also measurement of humidity plays a very important role. In environmental factors, like to measure the weather conditions in weather departments, the humidity measurements are done so that how it's affecting the environment and the temperature that can be seen. In electrical and electronic fields also, there are certain instruments which are to be used at some specific standard conditions only, and the humidity conditions are to be maintained for the use of those instruments and devices. So there also measurement of humidity plays a very important role. So we can see that in the various fields, the measurement of humidity is finding a wide variety of its applications. Now, before starting with the measurement of humidity and the methods which are used for the measurement of humidity, let us see some terms which are related with the humidity. So humidity, we have already defined that it is the amount of water present in the surrounding air. Now sometimes humidity is confused with the moisture. So what is moisture? Moisture is the amount of water present in any material or any substance, whereas humidity, it is the amount of water present in the surrounding air. So humidity is concerned only with the gases, but moisture is concerned with the water content present in either the liquids or the solids also. Okay, so moisture is defined as so it is the water content of any material or the substance, especially the solids and the liquids. Whereas humidity, it is the water content of only the surrounding air or the gases. Now next term is the absolute humidity. Absolute humidity is defined as the ratio of So humidity, we are measuring that it is amount of water content present in the air. So here the absolute humidity is defined as the ratio of the mass of water vapor, that is amount of water vapor, to the volume of the air. Okay, so we can say that it is the amount of water vapor present per unit volume. Okay, now if we define the mass of the water vapor as m, small m, and volume of the air as capital V, then absolute humidity is given as ratio of mass of water vapor, that is m, to the volume of the air. So content of water, the water content of the air per unit volume, we are called, it is called the absolute humidity. So absolute humidity is the ratio of mass and the volume of the air. Now here you have seen that this absolute humidity, it does not take temperature into its consideration. However, it changes with temperature. Okay. Now here temperature is not taken in account. But this absolute humidity, it changes with temperature and pressure also. Next is relative humidity. Now, whenever we talk about that, we are measuring the humidity of the air or something, we are measuring the humidity, then we talk about the relative humidity. Okay, so relative humidity, it is again the ratio of the actual water vapor present and at some specific temperature, and the ratio of the mass of the water vapor present at a given temperature when this air is being saturated. Okay, so relative humidity, ratio of So, relative humidity is defined as the ratio of the actual water vapor pressure present in the air at a particular temperature to the maximum water vapor pressure which can be present in the air at the same temperature. So, it is the ratio of the actual water vapor content to the maximum water vapor content present in the air. Okay, so relative humidity, that is RH, is the actual water vapor pressure to maximum water vapor pressure. Means when the air is having 100% humidity, that means the water content, the air is completely filled with the water. So maximum water vapor pressure, and both these measurements are done at a particular temperature. So we can see that absolute humidity was not taking temperature in account of it, but relative humidity, it taking the temperature also in its consideration. So relative humidity, it changes with temperature also, and it depends on temperature. Okay. So whenever we are doing the measurements of humidity or we are defining the humidity, we talk about the relative humidity of the air. Okay. Next is specific humidity. Specific humidity is defined as the ratio of the mass of the water vapor to the mass of the air. So if we are taking an amount of air in and we want to find out that what is the specific humidity in that, so what we will measure? We will measure the mass of the water vapor present in that air plus the total mass of that air. Okay, so that is defined as the specific humidity. Next is mixing ratio or humidity ratio. Now, mixing ratio is defined as the mass of the water vapor to the mass of the dry air. Okay, means that how much water vapor is present in how much amount of the air. Okay, what is the dry content of the air and what is the wet content of the air. So that is the mixing ratio or humidity ratio, that how much amount of humidity is present with respect to the dry content or dry. So you can see that in specific humidity we are finding the ratio of mass of water vapor to the total mass of air. But here mixing ratio is the ratio of mass of water vapor to the mass of the dry air. Okay. Now there is last term which is called the dew point temperature. That is also commonly used when we are doing the measurements of humidity. So dew point temperature is the temperature at which the water content or water vapor content present in the air is maximum. Okay, or we can say that the air is completely saturated with the water vapor. So temperature at which the water vapor content is saturated or it is maximum in the air, that is the dew point temperature. So relative humidity, that was also related with temperature. Okay, so relative humidity, if we say that the air is having 100% relative humidity, it means that it is having 100% means maximum humidity is present, and that temperature is called the dew point temperature. Okay, so relative humidity is 100% means that the air is saturated, it is having the maximum amount of water vapor content present in it. Okay, so these are some of the terms which are related with the measurement of humidity. Okay, now let us come to the devices or the methods which are used for the measurement of humidity. The device which is most commonly used for the measurement of humidity is known as hygrometer. So hygrometer is the device which measures the humidity directly. It gives us the readings of the humidity, and that humidity is the relative humidity of the air. Now these hygrometers, they are classified into various types depending upon the method which is used for the measurement of humidity. So there are various types of hygrometers, and these types are classified on the basis of the method used for the measurement. So if it is using some electrical methods to measure the humidity, then it is called the electrical hygrometers. The electrical hygrometers, they are based on the principle that humidity is measured by measuring the changes in the electrical parameters like resistance, capacitance, inductance or impedance. Okay, so indirectly the humidity is measured. So we can say that they are a type of transducers also, which measures a non-electrical quantity by measuring and which convert a non-electrical quantity into an electrical quantity. So humidity is a non-electrical quantity and that is converted into an electrical quantity. So electrical type of hygrometers, they measure humidity by measuring the changes in the resistance, capacitance or impedance. So if there are any changes in the electrical parameters due to the humidity, those methods are called the electrical methods. There are other methods also like thermal conductivity, crystal hygrometers are also there. Aluminium oxide hydrometers are also there. So depending upon the method used for measurement of humidity, there are different types of hygrometers. So here first we will start with the resistive methods, that is the electrical methods which are used for the measurement of humidity, and in that first is the resistive method. So first type is the resistive hygrometers. There are some materials whose humidity changes with the whose resistance changes with the change in the humidity. So such materials are used in this resistive hygrometer. Okay, the main part of the resistive hygrometer is the material whose resistance is going to change with the change in the humidity or the relative humidity. So there are some salts, or we can say some materials are there which are called the hygroscopic salts, and these salts exhibit a change in resistivity with the humidity. And this change, if a wire or electrode is used and that wire or electrode is coated with this hygroscopic salt, then that wire or electrode can be used for the measurement of humidity. Okay, because with the change in humidity, resistance changes, and change in resistance can be measured with the help of any electrical method like the Wheatstone bridge. Okay, so a wire or electrode is used, and that wire or electrode is coated with the hygroscopic salt. The example of such hygroscopic salts whose resistivity changes with the change in humidity is the lithium chloride. Okay, so in the resistive hygrometers we will have a mixture of this lithium chloride. As the humidity changes, the resistance of this lithium chloride is going to change, and that change in resistance is measured with the help of a Wheatstone bridge. So if we see the diagram for the resistive hygrometer having the lithium chloride as a conducting film, so in the resistive hygrometer, these are the electrodes. The electrodes in wires, they are coated with the hygroscopic salt or the lithium chloride, or we can say the lithium chloride, it acts as the conducting film. In between. Okay, so the resistance of these electrode is going to change. Here we are having the leads, and this is the base. Okay, so this is one arrangement in the resistive hygrometer. Another arrangement is that again we are having the two electrodes, but here we are having the conducting film in the form of a zigzag portion is there. So these are the two arrangements for the resistive hygrometers in which the lithium chloride is acting as the conducting film. So as the humidity is changing, the resistance of the material is also changing. Like if we take the case of the lithium chloride, if the relative humidity is more, means that the content of water vapor present in the air is more. Okay, so relative humidity is more, then lithium chloride is going to absorb more moisture. And because moisture is being absorbed, water content is being absorbed, so its resistance is going to decrease. Okay, so you can say that as the humidity is changing, because the lithium chloride has absorbed the moisture, so resistance is also decreased, and this decrease in resistance is measured with the help of the Wheatstone bridge. So Wheatstone bridge, because it consists of 4 arms, and this bridge is balanced when the value of these 4 resistances is equal. The ratio of the resistances in the arms is equal, that is P by Q is equals to R by S. That is the Wheatstone bridge balance equation. So if in one of the arms this resistive hydrometer is being connected, so as the resistance is changing, the Wheatstone bridge is going to get unbalanced. Okay, because in Wheatstone bridge the ratio of the resistances in the arms is equal. Now as one of the resistance is this resistive hygrometer and its resistance is decreasing, so decreasing resistance causes increase in the flow of current. Okay, so the galvanometer So here in the Wheatstone bridge, this galvanometer, which was earlier showing us the null deflection because the bridge was balanced, due to the change in resistance, it is going to give us a reading of the current flowing in the circuit. So this current can be measured to give us the readings for the humidity. So you can see that the humidity is causing the changes in the resistance. Resistance is causing the changes in the current or the voltage, and this current and voltage measurements, they are a measure of the humidity of the material. So here, because we are using an indirect method, non-electrical quantity is converted into an electrical quantity, and changes in humidity are measured by measuring the changes in the resistance, current or voltage. So it is an indirect method of measurement of humidity. Okay, and this is the resistive method. Okay, so these are the resistive hygrometers where resistance changes are measured. Next comes the capacitive hygrometers. In the capacitive hygrometers, the changes in the humidity causes the changes in the capacitance. Okay. Now we know that capacitance is given by the equation C is equals to epsilon A by D. So here capacitance is equals to epsilon A by D, where epsilon is the permittivity, A is the area, and D is the distance between the plates. Now this permittivity, it depends upon the dielectric medium used in the capacitor. If we see a capacitor, then it consists of two electrodes or two plates are there. In between them we are having the dielectric medium. Okay, D is the distance between the plates and A is the cross-sectional area. Okay, so we can say that capacitance, it depends upon this dielectric medium, or we can say the dielectric constant. Okay, now there are some materials, just like in the resistive hygrometers, we use the hygroscopic salts or materials which exhibits changes in the resistance with change in the humidity. So there are some hygroscopic materials also which exhibits the change in the dielectric constant with the change in the humidity. So such hygroscopic salts or materials are used for the construction of the capacitive hygrometers. So the hygroscopic materials which exhibit change in dielectric with changes in the humidity, they are being used because humidity is related with the content of water vapor present in the air. So the presence of water vapor is going to affect the dielectric constant, and this change in dielectric constant is going to change the capacitance. So by measuring the change in capacitance, we can measure the changes in the humidity. Okay. Now in both of these cases, that the changes in the humidity causes changes in capacitance or dielectric constant, the change is very small. So for that purpose, this capacitance, it is included, or it is treated as a frequency determining element. So because the change in the capacitance is very small, so capacitor is included as a frequency determining element in the oscillator. So in the oscillator, it is going to generate a frequency, and another frequency is being provided with the beat frequency oscillator. So one frequency is being provided by the capacitor, other frequency is provided by the beat frequency oscillator. So both these frequencies, they are heterodyned. Heterodyned means that we will calculate the difference between these two frequencies, and this difference in frequency is a measure of the relative humidity. So this is how in the capacitive hygrometers, the relative humidity, the changes in the relative humidity is measured by measuring the change in the dielectric constant or change in the capacitance. Okay. Now if we talk about the response time, that how fast is the response of such hygrometers, then its response time is about 1 second. So it is having a very fast or high response time. Quickly it is going to respond towards the changes in the humidity and give us the readings or the measurement values. So these are the two electrical methods, the resistive hygrometers and capacitive hygrometers, which measures the changes in humidity by measuring the changes in the electrical parameters. Now another type is the microwave refractometer. So the next type of hygrometers which are used for humidity measurement are microwave refractometer. in microwave refractometer, this system, it consists of two cavities. Okay, so it has two cavities and each of the cavity is coupled with the klystron. Klystron is the material which produces the microwaves, so klystron is used. Now, because we are having two cavities, so one of the cavity is having the dry air and other cavity is having the mixture whose humidity we want to measure. So two cavities are present. Both of these cavities are having the klystron. One cavity is having dry air and another cavity is having the mixture whose humidity we want to measure. So in that mixture, water vapors will be present. Okay. So due to the presence of the water vapor, there will be a change in the dielectric constant. And due to the changes in the dielectric constant, the frequency of one of the oscillator is going to change. So because in dry air no water content is present, so there is no change in dielectric constant, its frequency is going to be constant. Whereas in the mixture, because water vapors are present, so there is a change in dielectric constant, so its frequency is also going to change. And this change in frequency can be measured electronically, and this change in frequency is the measure of the relative humidity of the mixture. So here, because klystron is used, so it is called a microwave refractometer. Oscillators are there. One of the oscillator is going to change its frequency due to the change in humidity, and that is how the humidity is measured. Now this microwave refractometer, it is used in very special situations only because of its complexity. So this method is very complex method. So it is used in some special applications only. Now the next type of hygrometer is the aluminium oxide hygrometer. So by the name you can see that here the hygroscopic salt or material is aluminium oxide. Okay. And this hygrometer is going to change its parameters like resistance or capacitance is going to change with the change in the humidity. So if we see its construction, then aluminium oxide is coated on an So in this, aluminium oxide is coated on anodized aluminium, and this aluminium oxide is going to exhibit change in the dielectric constant with respect to changes in the humidity. Okay, so here also dielectric constant is changing. Aluminium oxide is coated on an anodized aluminium. Let's see its construction. This outer electrode is made by depositing a very thin layer of materials like gold is coated over this electrode to form the outer electrode, and this is the inner electrode. Now this inner electrode is having some pores in it. Okay, some pores are present there. This is called the base of the pore, and this is the side of the pore, and these are the pores in between this outer electrode. Okay, now because the humidity is changing, so due to the change in humidity, the dielectric constant is changing, and this change in dielectric constant can be measured to measure the humidity. So first, dielectric constant is changing. Dielectric constant causes changes in capacitance, and this changes in capacitance can be measured with the help of bridge or some related electrical methods. So this is the aluminum oxide hygrometers. In these hygrometers, the errors are very less, and their response time is about 10 seconds. Okay, so response time is very fast, errors are less, and also the changes in the dielectric constants are very large. So only a single element can be used to make this aluminum oxide hygrometer and to measure the humidity. Okay. Now next type of hygrometer is the crystal hygrometer. Now in the earlier hygrometers, we have used the hygroscopic salts, which exhibits the changes in the dielectric constant, in capacitance and resistance with the changes in the humidity. Now there are some crystals also which also exhibits the changes with the change in the humidity. So some crystals are also there which are hygroscopic in nature. Okay, so such materials can also be used. Also, there are some crystals which can be coated with the hygroscopic materials. And examples of such are hygroscopic polymers. So there are some crystals which are hygroscopic in nature, and some of the materials, they are coated with the hygroscopic materials. Okay, some of the crystals are coated with the hygroscopic materials which are called the hygroscopic polymers. Okay, so these crystals are used in the frequency determination elements in the oscillator. So just like in the capacitive hygrometer, if there is change in humidity, if the capacitor is used as the frequency determination element, the frequency is also going to change. So frequency shifts due to humidity. So when these crystals, they are used as the frequency determination elements in the oscillator. So when the humidity changes, so these crystals are having the hygroscopic coating over it. So that coating is going to absorb the water vapors in it, and due to the absorption of the water vapor, there will be a change in the mass of these crystals. Okay, and this change in mass is going to give us a measure, because there is a change in the mass, so frequency is also going to change, and this change in frequency is going to give us an indication of the change in the humidity. Okay, humidity changing, so mass is also changing, and mass is changing, so frequency which is given by these crystals is also changing. Let's see the diagram for it. These are the electrodes. Okay, so due to the humidity changes, this crystal or this hygroscopic coating is going to absorb the moisture, due to which its mass is being increased and the frequency generated by it is also going to change. So with the help of these electrodes, we are connecting it in the oscillator circuit, where it is used to measure the changes in the frequency, and those changes in frequency are proportional to or depends upon the changes in the humidity. So this is how the crystal hygrometers, they measure the changes in the humidity and are used for humidity measurements. So here in this video we studied that what is humidity. Then we saw some of the terms which are related with the humidity, like relative humidity, specific absolute humidity, dew point temperature, moisture and mixing ratio. So these terms are related with humidity. After that, we saw the methods which are used for the measurement of humidity. First was the resistive hygrometer, then capacitive hygrometers, microwave refractometer, aluminium oxide hygrometer and crystal hygrometers. So these are the different methods through which the measurement of humidity is done by measuring the different electrical parameters, and these parameters are changed due to the changes in the humidity, like resistance is changing, capacitance is changing, dielectric constant is changing, frequency variations are there. So indirectly the humidity is measured by measuring these parameters. So I hope that this topic is now clear to you. Thank you.